Hi everyone, welcome to Educon Community Java interview series. So today we will discuss about the HashMap and HashSet. So what are the internal operations and what are the main components of it? So this is a must know for Java interviews. So let's start. So one of the most commonly asked questions in Java interviews is the internal working of HashMap and HashSet. As you know, and it often feels overwhelming to cover during the last minute preparations, but once understood it helps crack interviews across all the levels. So interviewers expect the candidates to know such fundamental data structures used in daily problem solving. So just discuss. So like, how does this bucketization work? So a has function. hmm, A hash function computes a hash value for a key, and the hash value maps to a bucket index in an array. And if two keys map to the same bucket, then there will be a collision. Okay, but we like suppose I'm telling you here. So suppose here one key and value. Okay, so through the hash function, we are getting the hash value for a key. So suppose your key is 1, next your key is 11, right? And you are doing the hash function. How you are doing this hash function? By modulo 10. Okay, so when you will do 1 modulo 10, you will get as 1, right? So again, when you are doing 11 modulo 10, then again you are getting as 1, right? So in this way you are getting the uh, same hash value for keys. Okay, so if two keys map to the same bucket, like this one, okay, your hash value for 1 is also 1 and your 11 is also 1, so there is a collision. How we will resolve this? So to resolve this, we have the chaining. See this chaining concept. So this is nothing but the linked list or the tree based structure. And also we have the probing. Okay, so like open addressing techniques like linear or quadratic probing. Okay, so now what is the collision handling strategies in HashMap? So like chaining used in Java's HashMap. So like each bucket contains a linked list of key value pairs where each node represents a key value pair. So like if collisions increase, so Java 8 Plus dynamically converts this linked list into balanced red black tree. So this is the main important thing. So it mainly happens when the size crosses the 8. So let's see. Suppose for this key there is a key value pair and I am denoting this as A. Okay, and this one is like as B. So when there is collision in the same bucket, suppose mm, 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 okay, so suppose this one is one bucket and this one is another bucket. Okay, and now what is happening? This A bucket is linked with this B bucket, right? But how many times it will be continued? So suppose another bucket as collision happened, so in this way linked list chaining is going on, right? So 1 2 3 4 5, then 6, then 7, then 8. So when this linked list size uh, crosses the 8, then This linked list will convert into balanced red black tree. Okay, so it will be converted in that way. So this is called the treeification. 1 2 3 4 5 6 7. Again you can also like draw like this. So this is nothing but treeification. Clear? And what is this tree? This is balanced red black tree. Okay, so here see, like the main point is like when the list size crosses 8, then improving the search time from big O of n to big O of log n. So treeification. So converting linked list into the red black tree when bucket size exceeds a threshold. So what is the threshold value? This is 8. Okay, to improve the performance. Now next is optimizations. So the head of the linked list sometimes points to the last accessed key value node, and it improves the retrieval performance when searching within the list. Okay, so this is one strategy, that is chaining. Next is open addressing. So used in hash set, hash table, and some concurrent maps. So instead of using a separate data structure like a linked list or tree, so open addressing stores all key value pairs directly inside the array and finds an alternative positions in case of collision. Okay, so what is happening here? So like if we want to do this, like we need to implement another data structure. So without doing that, we are doing what? Open addressing. So it stores all the key value pairs directly inside the array and finds an alternative position in case of any collision. Then here it is linear probing. So find the next available slot sequentially. Then is quadratic probing. So use the squared increments to reduce the clustering, like 1 square, 2 square, 3 square, in that way. Next is double hashing. So use a second hash function to determine the next available slot. Okay, so suppose, see, uh, here we are getting this 1 percentile 10 equals to 1, then again 11 percentile 10 equals to 1. Here we are getting the same. But if we are doing in that way, like suppose if we will do some another way, like at first without doing modulo, first step if we will do like 1 mm, into 10, like multiplied by 10, this is suppose 10, and 11 multiplied by 10, 110. Clear? Now suppose we are doing mm, this 10 modulo 5, or not modulo 5, suppose divided by 5, this is 2, and then 110 divided by 5, this is 22. So suppose here we are using double steps. So this is the uh, first step has function, and this is the second step has function. And here through these two has functions, we are getting the different values. Like first one is 2, second one is 22. And in that way, we are storing this value in the second block and another one in the 22 end block. Okay, 20-second block. Okay, in that way we also can reduce the chaining. Yeah, but the main problem will be here, like if we will do like this, then many blocks will be created, so maybe there will be huge memory space can be used. So that's one lacuna for it. So according to the case, so we need to implement the things. Next is HashMap implementation details. So like uses chaining plus treeifications for low collision rates and efficient searching. Next is like hash collisions are reduced by dynamically converting the linked list into the red black tree, whatever I have discussed here, when entries in a bucket exceed 8. So treeification ensures the lookup remains big O log n instead of big O of n. So you know, right? Big O of log n, that is like more efficient, okay, instead of big O of n. So in high collision scenarios, so if elements drop below 6, and it will revert back to a linked list. So if the elements will again like some will be deleted, and after that if the nodes count will reduce to 6 or less than that, then it will again convert into linked list like this, in that way. Okay. So why does this matter for interviews? So like almost every Java interview includes a question like has maps internal mapping, and lookup time remains big O of 1 in low collision cases, and big O log of n in high collision scenarios, and performance optimizations. Okay. So suppose here it is array of linked list or trees called as buckets or bins. So this is node A null, then node 1, node say in that way, like index 0, index 1, index 2, index 3. Okay. So then here it is the like tree. So node A to node B and node M, node C. In that way, this is the tree. And here this the thing is like linked list. Okay. So I hope a little bit things are cleared here through these concepts. So if you have any other questions, so you can also ask me. So here the main part is like HashMap internal works, and inside it, like this, like the chaining concepts. Next is linked list to red black tree RBT, and the vice versa as well. And yeah, so collisions and how we overcome the collisions. So these questions can be asked in the Java interviews. Okay, so be clear with it. Hope you have liked it, and that thus just like and subscribe, and also share the content with your friends, and like the content if you uh, if you will think like it will be helpful, and also it will be motivational for me as well. So just keep supporting, and also like if you have any other questions, any other topic you need to discuss, like you were thinking like this topic is important for Java interview, so just post it in the comment section. So I will take it, and we'll discuss the thing. So that's how we will like share the knowledges with others, and also we will increase our knowledge. Okay, so sharing is caring. So just feel free to share any questions or any concerns, right? So goodbye, again we will discuss some another topic. Thank you.